Hey everybody! Today we're talking about symmetry, and we're recognizing lines of symmetry for given two-dimensional figures and identifying line symmetric figures and drawing those lines of symmetry. So what is symmetry? Symmetry is when you can take a shape or a figure and fold it in half, and then you'll have a mirror image on both halves. And so what I did was I made an example. So if we have a square, I can fold this square in half and have nothing overlap or fall over the edges. It's going to be the same on both sides. So here's my square, and I'm going to fold it in half. Okay, if you look, there's nothing overlapping. Both sides are the same. They're mirror images of each other. And so there's a line of symmetry. And so if I draw my line of symmetry on where I folded, there's my line of symmetry. And a lot of times you'll see it as a dotted line, but I think that this would be easier for us to see right now. So there's my line of symmetry. It's just where I folded. There's sometimes more than one line of symmetry because I can fold the square vertically or the hot dog way, or I can do it horizontally, the hamburger way. So if I fold it the other way, I still have nothing overlapping. Both sides are the same, and so that's another line of symmetry. So let me trace that line, and actually I'm going to do it in a different color so you can see. So far our square has two lines of symmetry. We're not done yet. I can take these two corners and match them together to make triangles, and you can see there is nothing overlapping. Okay, both sides are the same, so these are lines of symmetry. So let me put that line of symmetry on. Okay, but we're not done yet, because if I can fold those corners together, then I can also do the other corners. So let's do that too. I'm going to take this corner and this, oh, that's the one I just did. I'm going to do this corner and this bottom corner, and I'm going to match those up. And again, we have two even triangles, nothing's overlapping, it doesn't match. They're mirror images of each side, and so that's another line of symmetry. So I will draw that line on there. So sometimes symmetry is kind of fun because we get to play and we get to fold and we get to imagine if we folded this image or this figure, what would happen? Are both sides mirror images of each other? But sometimes not all objects are symmetrical. So if I take this triangle, for example, if I fold it, it doesn't match. I've got a pointy side, I've got a flat side, they don't match. And it doesn't matter how I fold this triangle, it's not symmetric. Okay, nothing is the same when I fold it. There's no equal sides or matching sides or mirror image sides. So this figure is not symmetrical, but our square is. So let's see how this is going to look on paper. Let's get started. Okay, so now that we know what symmetry is, and we know that we're pretending that we're folding these figures, let's circle the figures that have correct lines of symmetry drawn. So if we look at A, I'm going to look at both sides of that dotted line and decide if I folded that, would they line up? Would this point here match up with this point here? Would this corner match up with this corner? And they would, so this is a figure that has correct lines of symmetry drawn. But if I look at B, and I'm looking at these same points, if I look at this point and look right across, there isn't a point over here. And same over here. There's not, this bottom right point has nothing to match up at the top. And in fact, this figure has a pointy top, but a flat bottom. So this figure does not have correct lines of symmetry drawn, so I will not circle that figure. Now that we've been able to decide if a figure has correct lines drawn, let's find and draw all the lines of symmetry for the following figures ourselves. We're going to write the number of lines of symmetry that we found in the blank underneath each shape. So if we look at A, again, I'm going to look at the points. So if this point, the upper left, will meet the upper right, yes it will. Will the bottom left meet the bottom right? Yes it will. So I know if I folded this shape right down the middle, then that would be a line of symmetry. It would match. But let's look the other way. I'll erase my points. What if I want to fold the hot dog way or the hamburger way? Will this point match down at the bottom? No, it won't. It doesn't line up with anything, and the other side doesn't line up either. So there is no other line of symmetry. So this shape has one line of symmetry. If we look at the arrow, again, I'm going to match up the points. If I go vertically up and down, would the top point match the bottom? Yes, it would. Would the side points match? Yes. Yes. So I know there's a line of symmetry down the center. Now let's look if I fold it horizontally. Will this point match with that point? Yes. Will this point match with this point? Yes. So I know I also have a line across. I can fold it either way. And so this figure has two lines of symmetry. Then we have this funky cloud, and it's got all these different curves and edges, and every side is different. So this shape does not have any lines of symmetry because all the edges are different. They won't match up. So there are 0 lines of symmetry. So we know how to decide if a figure has correct lines drawn. We've practiced drawing our own lines. So now, can we see half of a figure and draw the other half to make it symmetrical? What's nice is that they've given us grid paper, and so I can follow the lines. And so what I'm going to do is count what is the length of this top part. And I see 1, 2 boxes. So when I go over, I'm going to go 1, 2 over. And now it goes diagonal over here. So let's count how many boxes am I going to go through. 1, 2, 3. And so I'm going to go through 1, 2, 3 boxes. This is not very straight. Ours, of course, will be straight if we're using a pencil. And then let's look at the length at the bottom. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's a little straighter. So let me just fix this. So if we look at this shape, that's better. I've made it symmetrical. I've made it match the other side.